Okay, on this video I am looking at solving these two problems here on IPv4 subnetting. And in the first one, which is number 8 here, I've got a Class B private network space, which is a /16 network space broken into /18 subnets. I'm using fixed length subnet masks, so all the subnets have the same size. That immediately gives me 2 bits for the subnets, 14 left for the hosts. 16 plus 2 is the 18. That's how I get 2 subnets. I can draw this picture here like I typically do to help me keep it all straight. I recommend this. I've got 4 octets for my IP address. I have n is equal to 16 because I'm starting with the Class B network. And I'm going to a /18 to subnet it. And so I get 16 plus 2. And then I've got 6 and 8 left here. And I've got now S is 2, and I have H is 14. Now this gets a little bit trickier because now we're going to have our increments are going to be in the 3rd octet. And there's this general rule that says the rightmost S bit is going to give us the increment value. And we have 2 S bits here at the left side of the byte. And the first placeholder is the 128s, the second is the 64s place. And it's the rightmost S bit, the binary place value, that gives us the increment. And so our increment is 64. Okay, I'll call that my delta. And so I'm going to get an increment of 64 in the 3rd octet. And exactly what is happening here, as you can see in the table when I make the IP addresses, 172.16.00, 64.0, 128.0, 192.0. And let's see, I'm going to add 1 to each of those for the first hop IP. That's easy. The broadcast address, you got to watch out now. Subtracting 1 from 64.0 is 63.255. Subtracting 1 from 128.0 is 127.255. 191.255. And finally, the next one would be 256.0. And so 1 from that is 255.255. And you can see there are a lot of IP addresses in each of these. As a matter of fact, we have 64 slots here and 256 in each of those 64. So 256 times 64 is 2 to the 8th times 2 to the 6th, or 2 to the 14th, which is H. Okay? So that's how you do that. And here I use the general rule that the rightmost S bit place value is equal to the increment. And the byte where that occurs is the byte at which that increment happens. So this is an increment which is occurring in the 3rd byte over, okay, the 3rd octet. And that's why we have the deltas occurring there. Okay, hope that helps. Let me go ahead and do the next one, which is very similar. Here we start with the Class B again, and we go to a /22. Let's draw the same picture. And so I'm going to start with a /16, so I have 8 and 8 for n being 16. Now I'm going up to /22. 16 plus 6 is 22, so I'm going to have 6 bits here for S. I'm going to have 2 plus 8, or H is 10. So I'm going to have 1,024 2 to the 10th IPs per subnet, and I'm going to have 2 to the 6th, which is 64 subnets. And I'm going to go ahead and use this same rule here, the rightmost S bit, the placeholder for it. And the rightmost S bit is in the, let's see, it's the 3rd bit over, and the placeholders are 1, 2, and 4. So the increment is 4, and it occurs in the 3rd octet. Okay, and you can see that's exactly what happens here. I have an increment of 4 in the third octet. And so I have H is 10, S is 6, as I said. And let's just double check here. We're supposed to have 64 subnets. And I didn't list them all. I put an ETC here. That would be a big table of 64. But I'm starting 0, 4, 8, 12, dot, 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 248 up to 252. The next one would be 256, but we don't write that one. And so that really is 256 divided by 4 really is 64. And so if we count by 4s up to 256, I am going to get 64 subnets. Okay, let's add 1 to the subnet IDs. That's easy. Let's subtract 1 from the subnet IDs. 4.0 minus 1 is 3.255. 8.0 minus 1 is 7.255, etc. And let's see, the subnet mask has 6 1s and 2 zeros in the third octet. So I'm going to have 255.255, and then I got 6 1s and 2 zeros. What I'm going to do is I'm going to say all 8 1s would be 255, so I'm going to go 255 minus 3 and get the 252. Okay, and so I think that does it here on these two problems. Hope that helps, and this is important cases of this rightmost s bit rule giving us our increment value. So hope that helps.